One of my clients wanted to implement an LLM that chats with historical data. So this historical data was saved in a form of PDF files. So their idea was that they can take the contents of these PDF files and directly load it into the context of the large language model. One of the main issues with that is at some point, the size of these files is going to exceed the context window of the LLM. So the token limit is going to be exceeded, and therefore you cannot fit more PDF files into the context of the LLM. Even if the contents of these PDF files actually fit into the context window of the LLM, when the LLM processes it, it's going to get more expensive. So when you load the full contents of your PDF file into the context of the LLM, you're going to be wasting resources, because to produce an answer to your question, the LLM doesn't need access to the full contents of these PDF files, and therefore you're wasting resources. The latency of your system will increase, and also the cost of your system will increase. And at some point, you're not going to be able to fit your data directly into the context of the LLM. So the proposed solution for this is to use a workflow that enables us to take these PDF files, to pre-process them, to split them into chunks. And then when we want to answer a question, what we do is that we do similarity search with the user question, and then we extract only the parts from the data. For example, this part contains something, some important information, this part also, and also this part. And then we're going to put that in the context window of the LLM. So instead of loading the full PDF file, we only now load parts of the data that are relevant to the question, that will enable the LLM to answer the question. And then we answer and give the sources that enabled the LLM to answer the question. So one proposed solution or one proposed method is Gemini file search. So Gemini file search has been introduced recently, and it's actually one of the most appealing solutions. Why file search is better than the other alternatives currently? First of all this process is fully managed for you and done for you by Google. All these steps that I just explained to you right now can be done directly by the Google file search. The second reason is that it is significantly cheaper than the other options. So for example, to store the documents in your database, Gemini file search can store it for you for free. So this is significant. Like no other provider, Supabase, Pinecone, OpenAI, Quadrant, Weaviate, Chroma. Chroma is a self-hosted, so you eventually need to pay for the infrastructure. So you need to pay for the servers that they're going to store the data and the engine for that. Gemini file search provides that for free, at least for now at the time of recording this video. Also, during the search time, the querying to do this matching and to extract the relevant content from the database, this is also done for free by Gemini file search. The only thing that you need to pay for is the indexing cost when you split your data into chunks and when you want to put these chunks in a vector store, because you need to generate the embeddings for that, and therefore they're going to charge you 15 cents per million token. So $15 per 100 million tokens. Therefore, compared to other options, Gemini file search seems to be the cheapest solution. And in a moment, we're going to take a look at the accuracy. Like, does that match the accuracy, or is just the cost is cheaper? How does it work? And is it different from any other RAG pipeline? So first, we have the documents. Then we're going to store these documents, and we're going to generate the embeddings. So these embeddings are going to be generated using an embedding model. So the embedding model is going to take the contents of these chunks from the data, and it's going to convert them into vectors. So it's going to be just like vectors of numbers, and these vectors of numbers, we're just going to make it easier for the LLM to do the similarity search, to extract the relevant contents to answer the question. And now we save it in a database, in a vector database. So this process is called the indexing process, happens offline and happens one time. Okay. So now during the querying, which happens real time, the user is gonna ask a question to Gemini model, and then the Gemini model is gonna decide whether this question needs access to external knowledge source to answer it. If the question is simple, that we can answer it directly, like it's a greeting or something like extremely simple, then it's gonna just return the answer directly. Otherwise, it's gonna generate a query or a list of queries to be able to extract the relevant information from the database. So this query will go to the embedding model, and the embedding model will then generate a vector, also another vector here, and this vector is gonna be matched with our vectors to extract the vectors that are relevant to answer the question. So after that, these chunks are gonna be passed as context to the large language model, to Gemini, and then Gemini is going to give us the final answer. Okay, so now let's see an example. So the dataset I'm going to be using for this example is this RAG mini Wikipedia dataset from Hugging Face. So you can find this dataset on Hugging Face. So it contains two parts. The first part is the text corpus, which is basically the text files that contain the data that we're going to save in the file search store. The second part is the question answer. So the question answer has a set of questions with their ground truth answers, so we can actually check the answers of the LLM. So to do that, I've created the script. So this script basically downloads the text files from this dataset. So overall, this dataset has around 1 million tokens. For the sake of this demo, I haven't downloaded all of them. I have downloaded only a subset of them that will enable us to test the accuracy of the extraction. First, I upload these files to the file search store. We index these files and then we put the vectors or the embeddings in the file search store. And then we ask the questions. So the first question was Abraham Lincoln the 16th president of the United States? So the ground truth answer says yes. So yes, Abraham Lincoln was the 16th president of the United States. So the answer is correct, but now we need actually to differentiate whether this answer came from the knowledge of the Gemini model, right? Because the LLM here, we're using Gemini 3 Flash. So maybe this answer already existed in the knowledge of the LLM. So let's check the citations to verify. Was the 16th president of the United States? So this is the citation. So the citation is correct and the answer is correct. So that's what basically we're interested in. We're interested to see whether the LLM have fetched the information and the knowledge that we gave it to, and whether it have sourced it or cited it correctly. So in this case, it actually gives us the file, exactly the text file where it got the information from. So now let's go to the second question. The second question was, did Lincoln sign the National Banking Act of 1863? The answer is also yes. So did Lincoln sign the National Banking Act? The answer was yes. President Lincoln signed the National Act of 1863. And now let's see the sources. So as we can see here, creation of system of national banks by the National Banking Act of 1863. So now let's go to the next question. So the next question was, did his mother die of pneumonia? Answer, based on the documents provided, specifically the article about Abraham Lincoln, his mother did not die of pneumonia. So that's correct. It's interesting to know that it does not only give us the source file, but also it gives us the source segment, the exact parts of speech or the segments that has been used to answer this question. So yeah, that was all I wanted to share with you. And here's a demo as well, just taking from the documentation. So thank you so much for listening. See you in the next one. Bye bye.